So welcome everyone to the Kentucky Center for Mathematics. Today is developing multiplicative thinking with our very own Lisa Riggs. Lisa, I look forward to learning from you today.
All right, well, I'm very glad to be here. Happy Wednesday to everybody. And we are going to think about multiplicative thinking and structuring number. So, and I would like to welcome you. I am Lisa Riggs, as she said, with Kentucky Center for Math. And just a reminder that you can find our information at KCM's website, which if you have been joining us, I'm sure you know how to locate that. But if you're new to us, we are housing our virtual PDs on our website. And today's agenda, we're going to take a brief look at what our standards are. We're going to be answering the question, what is multiplicative thinking? What is structuring? And look at some instructional settings that can help us with those things. So just briefly, as Kelly mentioned a little bit earlier, we are focused on those third grade standards with the basic facts for multiplication. And there is just a page out of Kentucky's common standards that we have for. And I've also included the word standards up here when you have your document is a link to our standards document. So for those of you that are out-of-state folks, as well as those in-state folks that may not have taken a close look at this, our standards really do have some nice benefits to them because there's not just the standards, there's also the clarification of the standard and that coherence, what comes before and what comes after. So it situates that standard in the progression, which I really love that. It also links to the standards for mathematical practice as well, which we're going to be talking about some of those today too. So one of our book study book that we did a few weeks ago was Math Fact Fluency. So if you were able to join us for that, this is not new to you. But as we're thinking about moving toward fluency with multiplicative thinking, we know that students come to know the basic facts as they progress through 3 phases according to Baruti. So phase 1 is that counting phase. If you joined Dee in her session yesterday, her focus was on sequencing and sequence counting, which does give kiddos the skill in order to start chunking numbers. And phase 2 is those derived facts. And phase 3 is that mastery, what we really want to see by the end of 3rd grade, where students are able to recall their facts. But we want that recall not to be based on memorization, but to be based on their conceptual understanding of multiplicative thinking. So today's focus is kind of between phase 1 and phase 2. How do we help kiddos move from having to count perceptual items to being able to think about groups of groups? Okay, there we go. So we want to think about student mathematical practice 7, I think was the most applicable to our topic today, which is to look for and make use of structure. Okay? And one of the books that we give out in our course, in our primary course, is that putting the practices into action, which that goes in depth with each of those practices. So if you're looking for a resource that's going to help the teachers within your building or to help you as well to understand those mathematical practices, this is a good resource for you to explain those a little bit more in depth. But we may be thinking about, well, just exactly what does it mean to have a structure to numbers? So when you think about structuring number, what is it that comes to mind? If anybody wants to unmute and just let me know what you're thinking when you think about that, that would be awesome. I see some people's lips moving, but I don't hear sound. So you have to hit your unmute if you're talking. And I understand it's that you may not want to put it out there in the whole wide world and on Facebook Live. I get it. Okay. So, but many people see math, and don't you, I even heard Judge Judy say yesterday on TV that math was hard for her. And I was like, really? I don't think so. But many people see math as confusing, and they're really not sure how things work, how all these things fit together and how they're achieved. But math is really quite predictable. And according to the putting practices into action, there's structure in math, and people that see that structure find that math makes sense. And that is the first mathematical teaching practice. Students should know when math makes sense. It should make sense to them. So we want kids to be able to do the things that proficient students do. They see the flexibility of numbers, being able to put them together, to take them apart, to work with numbers, to understand the properties and to see relationships, to recognize patterns and functions. And it's our job as teachers to help make these things explicit, and to help kids make those connections so that things do make sense to them, and so that they know when it doesn't make sense. Okay? We want kids to know when things make sense. So seeing those structures can help with that. Okay. So take a look at that image. How would you describe what you see? And you guys may be putting things in the chat, which I cannot see the chat at all. So somebody might have to fill me in.
I was going to type a group of red dots.
Yeah, it's a big group, isn't it? Okay, so it is kind of not very organized. And so let's take a look at this next slide. Now, how would you describe what you see?
It's a lot more organized now, and you can actually just count the rows and the columns and be able to multiplicatively be able to figure out how many it is. When the other one, you would actually have to count them.
Oh, yeah. Yeah. So this one has some organization. Okay, good. Thank you for adding that. So how is this one organized? How would you describe the organization?
A distinct group of two based on the colors.
Ah, yeah, so there we can see two groups because of the two different colors.
In the chat, people are talking about an array or groups of 4.
Okay, yeah, so we see rows and columns, we see an array, and we see that the arrays can be separated based on color. So there is some structure to it. Whereas if we look back at this, it was just scattered. I mean, you might start to see some groupings, but it's kind of hard to quantify that. Whereas like this, it would be much easier for us to organize it because there is some structure to it. Okay, so we can find that total by starting to chunk those amounts. So
one of the most powerful comments is that idea that it lays the foundation for distributed property. And I've seen that in action in a math classroom, and 100%. It is so powerful. So that visual picture helps the students to understand how they can break that down into a ×5 and a ×2. And thinking about those pieces together, it's very powerful. So thank you, Abby, for bringing that out.
Yes, and it builds on what kids know early on. So we think about, you may think, well, I'm only a first grade teacher. I'm really not thinking about multiplicative thinking. But for kids for this 5 and 2 to be useful, it starts here, right? It starts with knowing 5 and 2 on our fingers even. So the foundation plays a part in this multiplicative thinking as well. So seeing those structures early on, we can now apply what kids learned early on to the multiplicative thinking. And laying that foundation is so very important. Okay. So when I was thinking about where this multiplicative thinking begins and how we are in this new world of challenge, that we're doing things in distance and kids are at home, I was thinking about how could we get kids to start seeing things in groups, because that's where multiplication begins. We don't want kids thinking in unitary terms, but in groups. So in order to think in groups, one idea is just to come up with a Google slide and have kids put pictures in of things that in their world that come in groups. So I just made a couple of slides just to give you an idea of some things that kids might think about. If they have a bicycle, tires come in two. If they have a pet, I thought my cat has 2 ears, my cat has 2 eyes. Everybody has 2 feet. Right? We wear 2 shoes, and for whatever reason, my son had a picture of all his running shoes. So I was like, okay, how many shoes in Nathan's collection of shoes? Okay, we could count the shoes by 2s to come up with the total of shoes. We could also think about how many pairs of shoes. So one group of 2 is 1 pair of shoes. So we can start thinking about that idea of 2 being a group that is one thing. So that's a big idea, huh? Okay. So that was one slide or one way that you could think about that and get kids seeing things in chunks, not just in terms of one single item at a time. And then I thought, and there's just another example of things that come in 3s. Okay. Our triangle, the clover, tricycle, turkey feet, footprints. Okay. And you could do that for whatever multiple you're wanting kids to focus on. So they could add things that they see in their world to their multiples. Okay. Some of the items at home that can add structure to the multiplicative thinking as parents are working with their kids at home. I try to think about this as if my kids were still little, what would I be doing with them to help them build that multiplicative thinking? And I thought, I'd probably pull out the muffin tin and we'd put collections in the muffin tin. So I just pulled some muffin tins out of my cabinet and took a picture of those. But I also noticed that the muffin tins themselves make arrays. So we could use those arrays. And then if you add items to each, equal group items to each, then you've got a way to help kids to structure their thoughts about their collections. An egg carton can work as well. An ice tray, if you've got an ice tray, that would be another way that you could use that for structuring and to help add structure to your groups within those and help them with that multiplicative thinking. So those are just some ideas that you might share with parents if they haven't already thought about those things. Okay. And this is a little video that we're going to try to take a look at with the game called Snack Time, which does come from Developing Number Knowledge. I'm not going to play the whole thing, but just a little bit of a piece to show you how we can use this common items that you might have at home to help kids see the structures within multiplication. And this is a game, and hopefully my link will work.
Popcorn. Popcorn. It could be anything.
Okay, I'm gonna increase the play speed just a little because I think, and I won't play the whole thing, but if the link is tied to the presentation, so if you want to go back and watch the whole thing or share the link with parents, that would be a nice thing to be able to do.
Like thinking, if I'm going to be serving some popcorn, I will need a certain amount of cups to serve my popcorn, and I will need for a certain amount of people, right? And I will need a certain number. If I'm being fair, I'm going to give each person the same amount, right? So the game, lid, cloth, place for the dice to go. So for this also, you're going to need 2 dice. I have 2 different color dice here. That'll help me know which dice goes with what. So in other words, I'm going to put a little green dot on number of cups to remind me that that's the green dice. And I'm going to put a yellow dot at number of pieces per cup. So I remember that dice is for that. If you don't have different colored dice at home, you could use, you could use a deck of cards. You could do all the red ones would be the number of cups. And for this activity, I'm saying you start with 1 through 6 for each number of cups and the number of pieces per cup. So get out the ace through the 6 in a deck of cards. All the black ones would maybe be the number of cups, and all the red ones would be number of pieces per cup. So you'll have 2 different piles, and then that'll help you remember what each of them means. Just an idea if you don't have dice or something like that. And of course, if you do use cards, then you can take out the ace and maybe add a 7 for the number of pieces per cup or the number of cups needed. You can kind of adjust based on what your child is showing you and how they're doing. But you really want to make sure that the kids are talking about what they're noticing about the groups and noticing about the numbers and how they can count and things like that. So that's what we're going to be doing.
Can I write down the numbers?
Yes, please. Move this a little farther this way. I forgot that step. Eleanor is so awesome. She remembered that step. She's writing the dice amount. So 6.
6 times 4 is...
Yep, you could even put an X in the middle because 6 times 4 equals. All right, now you're going to figure that out. So how would you figure this out? Let's dump them out. There's 4 there.
Wait, hold on.
Wait, whoa, what? Put those back.
This is 8. That's 8. And that's 8.
Oh my gosh, so 8 plus 8 plus 8?
Mm-hmm.
All right, so
16 plus 8.
So 8 plus 8 is 16. You know that. There's a lot of kids out there who might not know that, and that's okay. If you know that 4 plus 4 is 8, and then maybe you might count out the rest. It seems like Eleanor knows that 8 and 8 is 16. So finish your counting.
17, 18, 19, 20.
Let's put that like that so we can see the 4.
22, 23.
Oops, 20.
Oops, 20, 21, 22, 23, 24.
Nice. All right.
Okay. All right, so that kind of showed us how to play the game. I really liked what that child was doing. So would anybody like to unmute and tell me what you noticed about her thinking as she was solving that problem and how she was using structuring to figure out that 6 times 4?
Well, I noticed that she used a double, which she's probably familiar with.
Okay. And I thought it was interesting as well. I think this is her mom, and of course she's making this video to share with all of us in this challenging time. So I applaud her for that. Okay, but she almost encouraged her daughter to count by ones, and her child said, "Wait." Okay, so
I saw that she wanted to use the counters, thinking of them as groups, and so 2 groups of 4 made an 8, and then thought about the 3 8s and looking for ways to group those.
Yeah, so she was looking for those structures. And yet, even when she laid the cotton balls on the table, I noticed they were in a pattern. There was a pattern of 4. They weren't just random. They were arranged in the pattern. So there was structure there. So she's starting to structure and to think about that. Okay? But, and she was beginning to have some multiplicative thinking, but she also had some counting to go along with it. So we're kind of bridging between the counting and the multiplicative thinking. Okay, but snack time is a nice little activity that you could do. You could use a muffin tin even to put your items in. Would be another nice way to do that. So that, as I said, is linked in the presentation. And when you go to that site on YouTube, in the comment section, it lists all the things that you need along with links to other things as well. So that's something nice to explore. Okay. Okay. A next step that you might want to try with helping kids to develop this multiplicative thinking with structure is just something as simple as dot cards, which I used quite a bit when I was an interventionist in the classroom. Okay, so in this setting, everything is visible. And so I have cards that I might lay out, and Dee was talking yesterday about how we have kids to do verbal sequences. One next step, we might do verbal sequences along with the quantity. If we're laying these cards down, 2, 4, 6, 8, 10, and they're visible. Or I might lay out that collection, and some kiddos at first especially might count those by ones, but I want to really encourage that grouping. Okay, so, but here we see each item and the group. Okay, so remember, for multiplicative thinking, kids have to keep up with 2 things, not just how many items, but also how many groups. So they're having to unitize. We're having to think of units of units. So that gets kind of complicated. So the next step would be to flip those over. Okay? And we call that distancing the setting. So we're kind of encouraging them to visualize or to think about what is not seen. And we don't want to leave everything. We don't want to jump from, oh, here you see the perceptual item, to now you have to remember just the symbol. Okay? So this kind of bridges that thinking. So when I flip those over, I'm going to make sure kids know, oh, there's 2 dots on each card. How many dots is that altogether? And that would be my next step. And after that, if at this point, they're having to keep up or attend to how many items in each group, but they don't have to keep up with how many groups. The group markers are still visible to them. So they're able to hold that. So the next step would be to screen that, okay? Distancing that setting again. So this time, if I lay them out flipped and add that screen, I'm going to say, oh, there's 5 cards under there. Each of those cards had 2 dots. Can you figure out how many dots that would be? Okay. So now they're having to attend to the 2 items. Units, how many units do I have? How many units within each unit? So units of units once again. Okay. Another question you can ask with that setting is, I have 5 cards under here, and each card has the same number of dots. There are 10 dots altogether. How many dots are on each card? Okay, which is a little bit more complicated of a question. Okay, here's just an example. As I was going through my pictures, I actually had an example of a child using dot cards to help them solve some bare number tasks. This was a child that was not quite ready for bare number tasks, but their classroom instruction was requiring that, so they were offered the support of some dot cards. Now, we wouldn't want to leave the student there with the dot cards, but it offers them the support in the moment. So instructionally, what might be my next steps if my child is needing, apparently working on 4 times 6, okay, after they're using the supportive cards, what would be the next instructional step, you think? And you guys can type it in the chat or unmute. Well, as the teacher, I'm going to be watching to see, are they counting by 4s? Are they skip counting? Are they counting by 1s? Are they able to see 4 and 4 is 8? And how are they thinking about this? Okay. And then my next step would be to flip those over. Okay. I don't want you to be able to see every dot. I want you to think about groups within groups. So that would be the next step, would be thinking about that. And then maybe even building an array. If they needed to do that, would be another step removed from just the dot structures. Okay. Which brings us to arrays. Okay. Within our classrooms, we might have arrays that are on paper, okay? But this is just an array that kids might see within their world. So what do you notice, or what do you wonder about this picture? Can you taste?
I noticed 3 rows of 4.
Yeah. Okay. So our question might be, how many bunnies are in the package? Okay. Or it might even be, how many ears are in the package? Because each bunny has 2 ears. So it can be whatever you want your focus to be. Okay. But we can think about how things are arranged in that array. So once again, if we add a screen, that's going to help distance the setting. So you could do this with just any array, a dot array, but if we add the screen to this picture of Peeps, now we have the group sizes visible along with the number of groups. So I know that each row has 4, and I know that there are 3 rows. Can I figure out, without seeing it all, how many there are? So being able to screen part of that is going to push kids beyond having to have visible items in that structure. Okay. And the next step might be to scoot this on over and cover up my group markers and say, oh, there's 4 in each row and I have 3 rows. How many would it be altogether? Okay. So if I gave them 2 packages, how many? We know how many are in 1. Could we figure out how many are in 2? And what happens if we add a screen? We know that this is 1 package. What happens if there are 2? How might students think about that? How could they think about that?
Some kids just may double it, knowing there's 2 if they already know what's in the 1 package.
Yeah, so we could think about that doubling, which is a good multiplicative thinking and a good place to start with that multiplicative thinking. Now, if we add another package, okay, and we don't want to leave everything visible, we want to throw a screen over it as well and get kids thinking about that. If we know 1, how could we figure this out? Okay. So this is actually some pictures that I had used with 2nd graders, and we were just, with my 2nd graders, of course, we were using that repeated addition to figure it out. Okay. But if we were thinking about this in terms of multiplicative thinking, we could do it with higher grade levels as well. But when I use these pictures with my students, then they started seeing things in their world. They would come in and tell me, oh, we had a 6-pack of Sprite that had 2 rows of 3 and all the different things. It opens their eyes to the arrays that are in their world. So if we think about those kinds of things, kids start noticing the structures that are evident around them, and that's the mathematics that they see everywhere they look. Okay. Look around your room. Do you see anything arranged in an array where you are sitting right now? Anybody want to shout one out? I just reached over and picked up a pack of markers. They're arranged in an array. A 3 by 10. Wow, nice. Right. There's that. When I look at my window, the panes on my window are arranged in an array. I see a 2 by 4 pane on my window. I actually have an organizer hanging on my wall that has rows of 4, and there are 5 rows of 4 on my organizer hanging on the wall. So I can see arrays everywhere I look. Helping kids to open their eyes to those arrays that are around them and to quantify their world is an awesome way to get them thinking multiplicatively in this challenging situation that we have. It doesn't have to be a worksheet. It doesn't have to be a bare number task. It can be just what's going on in your world. Do you notice the mathematics around you? Okay, and getting them to just notice those things, to notice and to wonder. And that is the challenge, to get them to be able to do that and to see that. There's all kinds, even I know in this pandemic we think about how many rolls of toilet paper do we have, but yeah, okay, those things are arranged in structures within the package, and that can be a math problem and a real world one at that. So that is pretty awesome. My clicker doesn't want to click, sorry. Oh, now of course it took off. Okay, so we want to build on the structures that kiddos know. And so one of the things that a lot of our primary students know are 10 frames. They're very familiar with 10 frames. They're very familiar with dice patterns. Okay, I'm going to play just a short little clip of a student using conceptual multiplication fact practice using the setting of 10 frames and dice patterns, building on what we know from primary.
Oh, hey! Didn't see you there! You just caught me practicing my conceptual multiplication skills, as one does. All right, so this is how I'm doing it in a kind of fun way. An individual game you can play with your child or your dog. All right, so this is what you do. So first, I'm gonna take a deck of cards, and I pulled out all the kings, the jacks, the queens, and the jokers already. So take those out. Nobody wants those. Put them away. That's too complicated for us. And then what we're gonna do is we're just gonna flip this deck of cards, and I got 4. So what I'm gonna do is I'm gonna write out 4 groups of. This is where the really fun part comes in, because it's like uncertain. Like, what am I going to get, you know? And I'm going to take a dice and I'm going to roll it. 5. So 4 groups of 5. And so now what I'm going to do is I'm going to take my large multitude of dice, as many as you can find. Up to 10 is best. And I'm going to take, so I have 4 groups, and I'm going to take these dice, and I'm going to find 5. So 5, 5, 5. This is the challenging part, really. 5. All right, so now I got 4 groups of 5. And so now, since I have it laid out, it's really easy for me to conceptualize what this means. So I can count. I can go 5, 10, 15, 20, and realize that 4 groups of 5, which is equal to 4 times 5, is equal to 20. So it's totally okay if I need to count it out. And that's a really good way for me to conceptualize what that is. And so now if I was going to take this a step further, let's say I did it again. So let's say I did it again, but I kept the 5s the same. All right, so I'm going to flip a card, and now I got 7 groups of 5. Now, I actually don't know any 7 multiplication tables. I just don't understand them. So now what I can do to make it easier for me to understand, true story, is I can take another, so I have 4 groups of 5 right here. All right, so 4 plus 3 makes 7. So what I can do is I can take 3 more dies, and I can just understand that 4 groups of 5 is 20, and then 3 groups of 5 is added up to 7 groups of 5. So if I add 3 more, this is the really complicated part, because like, where is the 5? No one knows. Now this, I can now understand that this is 7 groups of 5, which is equal to 4 groups of 5 and 3 groups of 5 combined. So if I do this separately, I know that 3 groups of 5 is 5, 10, 15. So I know this equals 15, which means that if I take this, 7 groups of 5 is 20 plus 15, which is 35. So this is a really easy way to conceptualize what is multiplication, you know? That way you know that it's really just this and this added together. It's groups of 5, it's groups of whatever you're doing. So then I have this all learned out, so now I understand 7 groups of 5, 3 groups of 5, 4 groups of 5. I'm conceptually multiplying. So, should we do it again?
And if you watch that whole video, she does do it again, but my time is running short, so I'm gonna stop her right there. But it is linked in the presentation, so you can go back and watch it. You can share it with your families so that they can see how to use a 10 frame to structure a number. It is a nice way to use what kids already know about the structure of 10 to help them to be able to use that distribution of 5 and some more, or even their doubles, to help them to derive their facts and to practice. And so that is that structure. So hopefully that's a setting that your kiddos are used to. Actually, when I was doing a school visit earlier this year, I saw a student doing this, and I happened to snap a picture of their whiteboard. They were using the fact 7 times 7, and they just drew out the 10 frame and filled in dots to come up with their answer 49. So that was that student's idea of how to do it. I did notice that their structure was a 6 and 1 in each of the dots. So at this point, they're having to use some counting to figure it out. Okay? But as the more they work with this, the more they would be able to distance from having to have each item and habituate that fact, and it would become a known fact over time. Okay? So just a suggestion and idea, snapping pictures is a good way to capture student thinking, okay? Because on that whiteboard, it's going to get erased. So if you snap a picture, you've got it, and you've got their thinking. Okay, a resource that I do want to share with you guys, and I know my time is about to run out, so I'm going to explain it run through it a little quickly, is from our Kentucky Numeracy Project. It is task group 4437, which is Pop, Drop, Move It. And this slide just tells you the level progression, which is a very well thought out progression. I love the progression of this as well, because it moves from skip counting with visible items to that repeated addition with visible items to repeated addition with the dots hidden. It's that structure that we talked about a few minutes ago. And then we're moving to bare numbers, okay, which means that the groups are hidden and the items are hidden. And then we're going to apply what students knew about 5s and 2s to figure out their 6s or their 7s, okay? And then thinking about hidden the expression cards, which is a missing factor game. Okay, so that whole resource and that whole task group you can always find on our Kentucky Numeracy project, but it is included in the handouts. So the games for each of those, as well as the instructions for Pop, Drop, Move It, which I'm just going to tell you briefly right here, but I will tell you that I do have, a few years ago, I used this at a family math night and made a show me clip that runs about 2 minutes that tells the instructions for how to play the game. So, but I'm just going to tell it to you briefly because I don't really have time for that. But you guys probably know how to play Move It, or you may have heard it called Bump It. Whatever your answer is, you know, you can bump the other person. But the way that we generate the facts is we have popsicle sticks. In this instance, they have 5 blue dots and 1 red dot. For our 6s, to help kids structure those 6s as 5 and 1 more. And we just take the popsicle sticks, drop them on the table. Some of them will land face up. Some of them will land with the dots hidden. At first, we want kids solving with the visible items. Okay, but as kids are familiar and are familiar with those structures, then the next advanced level would be for them to pull out the ones that are the hidden ones, okay, and figure out what that total for the hidden items would be. And that would be their answer. So that is the 2 levels. And those are explained in our directions. But I will tell you guys, if you haven't used Pop, Drop, Move It, my kids loved it. I always loved it because I know kids are working conceptually to figure out their facts, and the kids love to play this game. So if you've used it, you might want to chime in about that in the chat. Okay. But all those resources are in our handouts, and our Developing Multiplicative Thinking continues tomorrow with developing multiplication strategies. And then on Friday, monitoring and assessing multiplication, how we come up with all those things, which are so very important. And I will tell you guys, the challenge for these days for us is what to say in such a short amount of time and how to get it all in. There is so many things that I did not get to share with you guys, which I really hate, but 30 minutes goes by so super fast. But remember to follow us on Facebook and Twitter and join our website. And hope to see you again. We love our Lisa, family.
Yeah, fabulous, fabulous session, Lisa. And we thank you for sharing all of those ideas. Indeed, we at the Kentucky Center for Math have such a passion for all this content. Trying to do it in 30 minutes is near impossible. But in our chat, folks are talking about those activities that you shared with us and how that moves students toward that mathematical fluency. And they want to thank you for all your great ideas. We'd love for you to unmute and kind of mention something that was your favorite today. Give Lisa a shout out.
Arrays in the real world.
Did you hear them, Lisa? They loved your real world. Must have loved your peeps.
I liked another way to use those 10Z dice is on that 10 frame, making the groups with the dice dots.
Mm-hmm. Always great. Lisa pulls in her expertise of knowing, having worked with students that need to see that visualization, but always bringing us back. That's her passion, to be able to come back and have the kids see it in multiple ways. We thank you so much for joining us for the Kentucky Center for Mathematics. This is number 3 in a series of 5. And so tomorrow we'll be here in the afternoon, again, thinking about those multiplication strategies. So we appreciate that you spent our afternoon with us. We'll see you.